what's going on? Let's integrate the inverse hyperbolic sine of x. Uh, I don't like dealing with the explicit form of the inverse, so we're going to use a little trick for this. And the trick is when you consider uh, a function, an invertible function, of course, for this case, and it's going to go to, let's say, b. There's f of b. And let's say that f of 0 equals 0. We can always shift things to make this true. So we have this nice little rectangle. We have a following identity. The area of the whole rectangle, which is b f of b, well, that is the area from the integral, 0 to b dx f of x of whatever function f that is, plus the remaining area. This remaining area, that is the integral of the inverse function. And now we'll write it with dy f of y. There's a fun little identity. We want to generalize this to just find antiderivatives up to a constant for inverse functions. And of course, this is an inverse function. Well, this gives us f of y inverse. More generally, let's say, oh, forgive me. More generally, if we consider things as a function of b, where the origin, it will just introduce constants everywhere. This will turn f of b into f of x, and we'll have x multiplying that. And then we'll have an integral. And just to keep things a little, yeah, I guess for clarity, I should do something like this. It's a function of x with a dummy variable, x prime, and we'll start at a lower bound, let's call it a. Will be a constant hanging around. Then we have plus a, well, actually, f of a, and going all the way f of x, dy, f minus 1, f of y. Well, we've just derived this following identity. All of these are just constants that we can ignore, but you need to keep track of this dependence going on. That's a little note I should make. So we have this identity where I'll just keep the top index for the dependence. Equals x f of x minus integral x dx prime f of x prime. That's a fun little identity. But we can do a little more. We usually don't like integrals of something to be with respect to a function of that. We just want the independent variable itself. So we're just going to trade f of x with x, and then we're going to trade x to f inverse of x. So we're going to have something like this. We just replace that. And then x becomes f inverse. And f, well, it's going to be f of f inverse. So it'll just give us x. And then we subtract off. Well, that will be f inverse. And then we'll have dx prime, f of x prime, because it's still a dummy variable. And this is exactly the identity we'll use for sinh. This formula seems a little. I didn't believe it when I first looked at it, but a good example case is to look at square root of x and x squared to verify that this works out. But we're gonna do out the integral of sinh, inverse sinh now, because we're lazy and we don't want to deal with logarithms. Okay, well, we'll follow just our formula. Do dx prime inverse sinh equals x inverse sinh minus, well, this will be inverse sinh again, dx prime, and then the function is sinh itself. The integral, well, the antiderivative of sinh is going to be cosh. So we're going to have this equaling x sinh inverse minus cosh of x prime evaluated at x prime equals inverse sinh. Now this goes back to a little problem I mentioned in an earlier video. How do we evaluate the cosh of inverse sinh? Well, you do it in the same way as you do it for trig evaluations. You draw a triangle. So our angle is going to be inverse sinh x, and then we're going to have x and 1 to make it the sinh of that be x. And then that leaves this as cosh of inverse sinh of x. We have the hyperbolic Pythagorean identity, which would be cosh squared minus sinh squared gives you 1. In this case, we're going to have cosh squared of sinh inverse of x, and then sinh of sinh inverse will be x, so we have minus x squared. So overall, we have cosh squared of inverse sinh gives you 1 plus x squared. Note that cosh is a strictly positive function. So we have cosh of inverse sinh is the square root of 1 plus x squared. And that gives us information for our integral. So we can finally say integral of inverse sinh of x is x inverse sinh, x minus, well, cosh of inverse sinh is root 1 plus x squared. And I'll just throw in the constant.